Let's talk about rules for exponents. There are 5 of these rules that we'll need to know. The first is the product rule. The word product means that we are multiplying two things together. For instance, x squared times x cubed. Notice that they both have the same base, x, and we're multiplying these things together. If we wanted to, we could write each of these things out in an expanded form. X squared means x times x, and x cubed means x times x times x. Now, if we forget the problem for a second and we just look at what we've written here, if we wanted to write this exponentially, how would we do it? There are 5 factors of x, so we would write this as x to the 5th. Now, obviously, we don't want to have to write it down each time and then count to see what we're going to have, so we need to have an easier way to get from our problem to our solution. The easier thing to do is to add the exponents. Here, 2 and 3 add together to make 5. So x squared times x cubed is x to the 5th, and the product rule says if we are multiplying two things together that have the same base, we should add the exponents. The quotient rule is when we're dividing two things that have the same base. Since dividing is the opposite of multiplying, it makes sense that we're going to now subtract the exponents. So if I have x to the 5th divided by x squared, 5 minus 2 gives us 3. So x to the 5th divided by x squared should be x cubed. We can see this in an expanded form. 5 factors of x on the top, 2 factors of x on the bottom. And since these things are being multiplied, we can cancel things out that match up with each other. These two x's will cancel with those two x's, leaving us 3 factors of x. With these 3 factors of x, we could write our answer as x cubed. But again, we don't want to have to write it in that expanded form. We much prefer to say anytime we are dividing two things that have the same base, we keep the base and we subtract the exponents, the top one minus the bottom one. Our next rule is the power rule when we are raising an exponent to an exponent. For this, we'll multiply the exponents together. For instance, if we had x squared that was being raised to the 5th power, we multiply 2 times 5 to get to our result of x to the 10th here. The power rule says that we're going to keep the base and we're going to multiply the exponents together. Now, this is the first rule that has a little bit of a trick to it. We have to be aware that exponents work on what is immediately in front of them. So as we look at our next example, this 2 exponent works on the parentheses that are right in front of it. That means that everything inside those parentheses needs to get squared. Not only are we going to multiply 6 times 2 with the exponents in order to get 12 as our new exponent, but we also have to take this 3 and square it. 3 squared means 3 times 3. 3 times 3 is 9. So our result here is 9x to the 12th. We multiply those exponents, but the 3 was to be multiplied times itself, however many times this exponent tells us to do it. Our next rule is the zero exponent rule. If we look at this example of dividing, we know that anything divided by itself should result in 1. So x to the 5th divided by itself should be 1. But if we think about our quotient rule that told us to keep the base and subtract the exponents, 5 minus 5 is 0. So for the arithmetic that is here to work, that means that x to the 0 power has to be the same as 1. In fact, anything to the 0 power is 1. Now, this one again has a trick to it. We have to be certain as to what the exponent is acting on. For instance, with our 2 problems that are here, one of these will be what you expect, the other maybe not. As we look at the first one, -2 in parentheses, to the 0 power. The 0 power is working on everything inside the parentheses since it's attached to the parentheses. Anything to the 0 power is 1, so our result here is what we expect. It's going to be 1. The next problem, though, when we look at negative 2 to the 0, it is only 2 that is being raised to the 0 power. The negative is not being raised to the 0 power. Exponents work on what is immediately in front of them, and what's immediately in front of the 0 exponent is just the 2. 2 to the 0 gives me this 1, but when I bring down my negative, the result here is negative 1. Now, I've shown you this with 0 being the exponent, but it's true for any exponent that they act on what is immediately in front of them. For instance, the one that is here, negative 2 in parentheses squared. This means negative 2 times negative 2, so our result is 4. The next one, negative 2 squared, is a little bit different. Here, the exponent works just on the 2 and not the negative. Exponents work on what is immediately in front of them. This 2, if you square it, would give you 4, but if you bring this negative down, our ultimate result is negative 4. Exponents work on what is immediately in front of them. The final exponent rule is the negative exponent rule, and it tells us that our base is misplaced. We should never leave a negative exponent. To fix it, we move whatever base it's attached to across the fraction bar, and then it will be a positive exponent. Remember that exponents only work on what is immediately in front of them. So for the problem that's here, the 2 is not in front immediately of that negative 3 exponent. It's just the x that is being raised to the negative 3. So the 2 and the 5 are good where they are. This x to the negative 3 needs to move to the bottom, and when we move it to the bottom, notice that now it has a positive exponent. Moving a negative exponent across the fraction bar changes the sign of it to a positive exponent. I showed you one with a negative exponent on top where we needed to move to the bottom, but we could also have something on the bottom that needs to move to the top. Here, the 3 and the 4 are not affected by this negative exponent. They'll stay where they are. 3 and 4 stay just where they were. But the x to the negative 5 needs to move. We never want to leave a negative exponent, so to fix it, let's move it to the top. When I move it to the top, now it has a positive exponent. Negative exponents tell us the base is misplaced. Move it across the fraction bar, and that will fix it.